Here's a final question on the trig exam. It's a little involved, but it's well worth the investigation. So let's analyze how to solve this one first. In its most general form, there are 4 coefficients we need to be worried about. Here's a theta plus a d. So each one of them does a little bit of different things very quickly. C squeeze a normal curve from the original one. D shifts the squeeze the curve left or right. And coefficient B here lift the curve up and down magnitude-wise. And lastly, the A offsets the entire curve. Okay, so this is what ABCD does to each one of the curve. Using our analysis earlier, we can see that B is equal to 10 because going from a 1 of a normal curve to -1, we have a factor of 10 and minus 10. That says magnitude is 10. And since it's centered on 0, that says A is equal to 0. We have no offset. So here, this one is 0. And this one, we know is 10, positive 10 here. Okay, so our curve is simplified down to this. What we have now is y is equal to 10 of sine c of theta plus d. All we have to do is find out what the c is and d is, we're set. All right, let's clean up our working space and solve c and d. A normal sine curve has 2 adjacent 0 points at 0. Let's call this one alpha. Alpha equal to 0 and alpha equal to 180. So what I want to do is pick the same 2 points, that's 2 adjacent 0 points, and use those 2 points to plug into the form I'm going to try to solve, which is 10 sine of c theta plus d. So the 2 points I'm going to pick is 0 when theta equal to 0 and y is equal to 0. That's the first point over here. And the second point I want to pick is when theta equal to 90 and then y is equal to 0 as well. Now you don't have to pick those 2 points. From experience, those 2 points are easiest to solve because left-hand side equal to 0. And that's a pretty easy 2 points the corresponding on my normal sine curve. What I did over here is I plugged those 2 points into this equation I'm trying to solve. So when theta equal to 0, I have a 0 on this side for y, and when theta equal to 90, I have another 0 again. Now from this chunk onto this yellow chunk here, that's a lot of students struggle, but you don't have to. So watch this sine curve normally over here. If alpha equal to 0 and alpha equal to 180, those corresponds to 2 points, to first 0 points anyway, where the sine function becomes 0. So stripping away the sine, this is what's going to help us to solve C and D. So basically I said, look, if this chunk inside, corresponds to alpha equal to 0, then I have sine of 0 times 10, which gives me the 0. Second chunk, if this chunk equal to 180, sine of 180 times 10, it's going to give me 0 as well. Again, this is the second point over here. Solving from this point onward is really just straightforward. From here, we have c equal to 2, d equal to 0. So our final equation is y equal to 10 times sine of 2 theta. That's this curve that's we were given. Hi, this is Dr. Pan, recording from Tucson, Arizona. Please comment or share this video. Together we can make math easy again. Have a confident day.